Okay, so last video here, we're going to be talking about, this is technically our 1-7. So this is going to be systems of linear inequalities. So what are systems of linear inequalities? The last one we did our linear inequalities, and it was a line, and you had to shade on either line. So it's the exact same thing, except this time there are two equations, which means there are two lines that have stuff shaded in. Okay? So our solutions for these, what are our solutions going to be for these? It's going to be any point that will make both equations true. It has to make both equations true. Or it's going to be the overlaps of the shaded area. Okay? So this point up here is not a solution. It's only true for one of the equations. This point down here is not a solution. It's only true for one of the equations. This point right here is a solution because it is a solution for both of them. So essentially your solution is going to be anywhere in this section here because that is where the purple and the red overlapped each other. Okay? Now, you guys can see that algebraically by plugging in these points like we were doing before. Okay? So the green point is at 0, 6. Green point is at 0, 6. So let's say I plug it into this one here. 2 times 0 plus 4 times 6 less than 6. Okay? That's going to give me 0. That's going to give me 24 less than 6. False. That's not true. Okay? However, when I do this one, 0 minus 2 times 6 less than or equal to 8, I get a negative 12 less than or equal to 8. Negative 12 is less than or equal to 8. So your green point is true for this one here, which is our purple. It's true for one, but it is not true for our red. It is only true for our purple, not in the red. So this one is not a solution. Okay? Now we're going to do the same thing with the blue point. So the blue is going to be true for this one, the top one here, but it's not going to be true for the bottom one. So you guys can see that here. For my top one, my blue should be true. So that point is at 6, negative 5. So 2 times 6 plus 4 times negative 5 less than, just a less than, sorry, less than 6. So 12 minus 20 less than 6 gives me negative 18 less than 6. So that is true, okay, which is what we expected it to be. Versus, when I look at this one, 6 minus 2 times negative 5 less than or equal to 8. 6, and then a negative 2 and a negative 5 gives me a positive 10 less than or equal to 8. So 16 less than or equal to 8. That would be false, not true. Which makes sense. My order was flipped. Last time it was false, then true. Now this one is true, then false, because it's true for the red, but not for the purple. Okay? So those are not solutions. It has to be true for both of them. Now, what is a solution? Well, we said our red point there was a solution. So the point negative 5, 0, that is a solution. So what that means is that'll be true for this one, and that'll be true for this one here. So 2 times negative 5 plus 4 times 0 has to be less than 6. The zeros are basically gone, so negative 10 less than 6. Yeah, that's true. Okay? Then I've got negative 5 minus 2 times 0 less than or equal to 8. Okay, again, zeros, basically don't worry about them. Negative 5 less than or equal to 8. Is that true? Yes, that is true. Okay? So if it's true for both, meaning it's the overlap, then it is a solution to the system. But it has to be true for both of them. So what we're going to do on these is you're going to graph one of the lines, figure out where it's shaded. Then you're going to graph the other line and figure out where it's shaded. And your solution, all the points that are in the overlapped part, are going to be your answers. Now, I do have a couple special questions to ask you. Like, for instance, this one here. The point negative 4, 0. Would that be a solution? The answer is yes. Negative 4, 0 is a solution. Okay. What if I asked you guys about the point 1, 1? Is 1, 1 a solution? The answer is no. 1, 1 is not a solution. Both of those are on the line, but you guys need to look at the line to tell if it's a solution. For negative 4, 0, that's on a solid line, which means we are including those. So we are including all the points on that solid line. Those would be solutions. They are including the overlap. But 1, 1 is on a dashed line. That means we are not including those points on that line. So if we're not including those points on that line, that means that I could not say that 1, 1 overlaps because it's on a dashed line part of it. Okay, so those are just a couple of tricks you got to pay attention to with those. All right. Now, you guys should remember all of the steps that you did, and if you don't remember them, you've got them in your other notes. You probably won't remember them because you've probably only done 2 of these. Okay? But anyway, let's pretend like you do. So what are our steps to do this? Well, step 1 is going to be to graph the first linear inequality. Guess what step 2 is? Graph the second linear inequality. And then step 3 is going to be to mark your answer. Okay? So, starting out, we're going to graph this first one. X plus 3y equals 6. Okay, remember we changed that greater than sign to an equal sign because we're trying to get into y equals. Minus x, 3y equals negative x plus 6. Divide by 3, divide by 3, divide by 3. Y equals negative 1/3 x plus 2. So positive 2. I'm going to go down 1 to the right 3, down 1 to the right 3. Could also go up 1 to the left 3, up 1 to the left 3. Am I going to have a dashed line or a solid line? I'm going to have a dashed line for this one. Okay. What would be the perfect test point to use for this? 0, 0 is always perfect. Okay, so when I do my test point, I'm going to plug it back into the original. So it's 0 plus 3 times 0 greater than 6. So 0 is greater than 6. Is that true? Is 0 greater than 6? No. So that's false. Remember, if we get a false statement, we're going to shade away from the test point. So since my test point's down here, I'm going to shade up top. I'm going to shade this whole section up top. Okay? So, good. We completed step 1. We graphed the first linear inequality. Now, we're going to graph the second one. 2x minus y equals 3. Subtract 2x on both sides. Negative y equals negative 2x plus 3. Divide by negative 1. Negative 1. Divide by negative 1. Y equals negative 2 divided by negative 1 gives me a positive 2x. 3 divided by negative 1 gives me a negative 3. So y-intercept is at negative 3. Slope is 2. So that's 2 over 1. Up 2 to the right 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 1. Okay, could also go down 2 to the left 1, down 2 to the left 1. Either one of those would work. Do I have a solid or a dashed line? Solid. So I'm going to start down here and take that on up. Okay. What test point should I use? We'll use the best test point. We can always use 0, 0 unless the line's running through it. So I'm going to go back to my original then. That's 2 times 0 minus 0 greater than or equal to 3. 2 times 0 is 0 minus another 0 gives me 0 greater than or equal to 3. Is that true? Again, no, that would be false. So false means we shade away from the test point. So if the test point's on this side here, we need to shade away from it, which would be on this side over here. Okay, so where is my answer? Okay, because I need to mark my answer. My answer is in the overlap section. So our overlap section is in this top right. So how can you guys mark your answer? I want you guys to draw an S in there. And you can make it, one of those cool S's like I just did there. You could shade in an S. Some people last year erased an S in it. But I need you guys to make an S in here, a big old bold S like this, to show me that you know where the solution is. So anything in that overlapped part would be a solution. Okay? All right. Okay, I want you guys to pause the video, try this one on your own. Pause the video, try this one on your own. Okay, for the red part, we got y equals negative x plus 5. So positive 5, negative slope, so down one to the right one. Do I have a dashed line or a solid line for this one? I'm hoping you guys said that this would be dashed because we're not including it. Okay, and then I need a test. What's the perfect test point? 0, 0. So I'm going to do 0 plus 0 is less than 5. 0 less than 5. Would that be true? Yes, that is true. So we shade with the test point since it is true. So I am shading with the test point on the same side as the test point since this is true. Okay? Next is down at the bottom. Negative 2y equals negative x minus 3. Divide by negative 2. Divide by negative 2. Divide by negative 2. Y equals a 1/2 x plus 3/2. Okay, remember when we deal with fractions like 3/2, okay, that's 1 and 1/2. So I'm going to go put a spot halfway in between. I've got to be careful when I'm finding my slope. I could go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. You could also go down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. Okay, I would need to have a solid line between these. Okay, what test point should I use? Well, 0, 0 is still available. So I could go 0 minus 2 times 0, greater than or equal to negative 3. So I've got 0, because that's all just 0 there, 0 greater than or equal to negative 3. Is 0 greater than or equal to negative 3? Yes, it is. So that's also true. So since that's also true, we're shading with our test point. So I'm shading on the same side as my test point here. So that goes all the way across. So where is my solution at? Well, my solution is the overlap between the blue and the red. Okay, so my overlap would be in this section here. That overlap between the blue and the red would be my solution. Draw myself a big fancy S or erase a big fancy S out of that thing. Okay? All right. One more situation we have here is a special situation. And that special situation is going to involve parallel lines. If I subtract both over, I get 3y equals negative x minus 6. Divide everything by 3 here, I get y equals negative 1/3 x minus 2. So you guys will notice those both have the same slope. Both slopes are negative 1/3. So I'm going to graph this one that I just put that red arrow with. It's at negative 2. Okay? And I could go up 1 to the left 3, or I could go down 1 to the right 3. Either one of those would work. And I'm going to use a dashed line with that. Okay? And I'm going to do a test point. Say I'm going to test 0, 0 for this one. So in red, I'm testing 0, 0. So 0 plus 3 times 0 is less than negative 6. 0 less than negative 6. That is not true. So I shade away from my test point down here. Okay? And I'm going to have to pause this video. The next video you guys have will just be like a minute long.